Hello, this is Module 3, Investigation 5, extra practice with the function composition. Okay, so let's see what kind of problem we'll get from here. So number 1. So I'll do number 1, A and G, but I think I want to go over every problem from number 1. So number 1, a pebble is thrown into the lake and placed to create a circular ripple. The radius length of the circular ripple increases at a constant rate of 7 centimeter per second. Your goal is to determine the area, which in the squared centimeters, inside the ripple in terms of the number of the seconds since the pebble hit the water. So draw the picture of the situation, label the quantities, and imagine how the quantities are changing together. Discuss in your groups with the processes need to be carried out to determine the area inside the ripple when the number of the seconds since the pebble hit the water is known. So when you have a lake, right? If there's a lake, and then if you drop the pebble, and then you see that the ripple goes out this way, isn't it? It's a circles, right? So pebble is right here, and then it makes a circles, right? So first one is the 7 centimeter, right? And then the second radius becomes the 14. And then this next one give us the 21, right? So and then it increased by the 7 centimeter per second. So what is the varying quantity? So the varying quantity is, I think the number of the second has been changed, right? Number of the seconds since the pebble hit the water. And then also the radius of the circle of the ripple, right? So radius of the circular, let's say circular ripple, but in centimeter. And then also the area also changes because the radius changing, right? So the area of the circular ripple in square centimeter this time. All right, B. What quantities are varying, changing in the situation, and how they're changing together? So as the time since the pebble hit the water increases, and how's the radius of the ripple changing? Yeah, it's increases, right? So the radius is increases. Increases. But how? At a constant rate of 7 centimeter per second. And then number 2, as the radius of circular ripple increases, how's the area? Of course, the area increases too. Okay. And then number 3, as the time since the pebble hit the water increases, how does area circular ripple change? Yeah, the area increases, right? So C, define the function f, determine the radius of the circular ripple in terms of the number of the seconds. So how the radius is increases? 7 centimeter per second, right? 17. So which means R is a 70, isn't it? R is actually the 70. Okay, now the D, define the function G to determine the area of the circular ripple in terms of the circular radius of R. So which is G of R, we're using radius pi R squared, isn't it? And this time is the area is about the G of R. So the f of t is the R, and then G of R means the area. And then describe the process of the evaluating for G of f of 4.5. Okay, so 4.5 is input for the f function. So this is the number of the second. And then give us the radius of the circle. And then radius of the circle give us the g function of area of the circle, right? Okay. So what we do is, in order to get the area of the circle of the g of r, and then r is actually same as f of t, but f of t is the same as, so the area, okay, so hold on a second. So area was actually the pi r square, but the r is now the 7t square. So it becomes 49 pi t square. So you can use the t as a second to find the area. So if you have that, so 4.5 is in the exercise g of f of 4.5 to describe the work quantity and unit measurement is associated with each of the following. So 4.5, and that means the number of the second, right? So which is, we can say it elapsed time. And since the pebble hit the water, which is we have to use the seconds, right? The 4.5 seconds. And the f of 4.5 give us the length of the radius, right? Well, of course, it's a circle, which is a centimeter. And then the g of f of 4.5, which give us the length, the area, area of the ripple. But it's going to be the circular ripple. And then give us a square centimeter. Okay. All right. Now in G, define the h functions that determine the area of the circular ripple. Okay. In the measures in the square centimeters as a function of the time t. Okay. So I think I already showed it to you. So in order to find the h of function is going to be the area. So area we call the h of the t. So h of the t is area. So what was the area? Area was the h of t is a g of f of t. And then the area function is pi r square, but r is the same as 7t. So you put the pi times 7t square. Simplify, 7 squares are 49, t squared pi t squared, that would be better. Sorry. Be the same thing, 7. Okay, and they equal to 49 pi t squared. And then compute the value of the h of 4, which is the same as g of f of 4. So h of 4, which means 49, and 4 means the times, right? 49 pi of the 4 square. And then you will get 49 times 16, which is 784 pi. And then g of f of 4. So f of 4 means we have to have a f of t was the 70, right? So f of 4 means 7 times 4, which is 28. So I put the 28 for the g functions. So the g function is pi r square. So r is a 28 square, okay? And then 28 square, it's going to be the 784 pi. So what do you see? It comes out the same. All right. Thank you for listening.